I want to welcome you all back for the 6th session of this first day of our triathlon of the MSENSE digital event. Our last session for today will be another FAQ session. So therefore, I want to introduce Christian Hofmeister to you. Christian is part of our MR family for more than 15 years now. He serviced tap changers for over 9 years before he moved on to automation as a portfolio manager. Christian will answer your questions together with Bastian Fischer, who you already know from our last session before. So let's begin with the first question, please. Bastian and Christian, come on up.
Thanks, Peter.
Thank you, Peter.
So the first question is, which sensors need minimum to become an intelligent transformer?
Okay, that's a good question. There are many aspects in that question. First, it's about intelligent transformer. What makes a transformer intelligent? Therefore, I would say before looking at sensors, we need to ensure that on the transformer we have the capability of storing data, performing analysis and evaluation of that data. For that we need a CPU and a powerful edge device, edge computer. So we collect data, we analyze and evaluate data on the edge computer. And lastly, we need to communicate the decision and support the operator or the asset manager with those evaluations. That makes a transformer intelligent. Furthermore, in order to make a transformer intelligent, we need also to make it safe and secure. Therefore, this powerful edge computer also has built-in cybersecurity means for encryption and authorizations to ensure that this intelligent transformer is well protected. Now, going to your original aspect, or to the other aspect of the question, what type of sensor do we need? Now, first we need a temperature, the load, in order to calculate the hotspots of the transformer. That's the minimum. The recommended set of sensors would be to expand and to include an analysis of the insulation system with the DGA by looking at the dissolved gases. I think two gases, hydrogen and carbon monoxide would be okay, would be sufficient as an indicator and an alarming system. And finally, I would recommend to, from the go, to include one aspect, one dimension of OLTC monitoring. You remember from the previous session, there are 3 aspects: MCI, motor current index, torque, and VAM. And the decision which of those OLTC principles are selected depends a little bit on the criticality of the transformer, also whether it's an old, a medium, or a new transformer. But if you remember one thing, the recommended set is temperature, a DGA3, and VAM. With that, we have a pretty complete sensing of all main components of your transformer.
Well, let me add something more.
Oh, sure.
When we speak about the common transformers and the minimum setup, I would also say if you have a typical transformer, you always have also protection devices like Buchholz or a RS2001 relay. Then the oil level maybe, if it has an interface like an analog signal or a digital signal. So that stuff, of course. And as a OLTC manufacturer, of course, we also like to connect also the motor drive unit and to have a digital operation counter and all the signals from our OTC.
Exactly. Thank you. Yes, that's both together will make it a complete package. Yes, thank you.
Thank you very much. The next question up, what is the benefit of an intelligent and connected transformer?
Good question, and I like that because our session has the tagline of intelligent connected transformer. It's clear we need to explain a little bit more what does it mean intelligent transformer and what the benefits are. The purpose of a transformer is to supply reliable energy and to avoid unplanned outages, and by the way, to optimize and dispatch your working crews into the field. And with all those three criteria, the transformer will help you in optimizing those three aspects. It increases the load and allows you for higher flexibility. How do we do that? That intelligence in ethos will give you an prediction and a high degree of automation on keeping the transformer at a steady temperature while respecting the forecasted load and the forecasted temperature. The second aspect is how do we know about the condition, and how does the dispatcher know whether that transformer is able to take and to cover a certain load. For that, ethos provides a dynamic health index, which simplifies and gives a single indicator on the health and the ability of that asset to take a certain load at a certain point in time. And thirdly, about optimizing asset management and work crew dispatch. Our transformers have a built-in time calculation about the needed duration or about the remaining duration of safe operation, which gives you the ability to prioritize which transformer needs the next maintenance. So on all those three topics, ethos, together with the intelligence, supports you in the operation of the transformer.
Thank you very much, Bastian. The next question, is it possible to integrate ethos in a SCADA system?
Actually, a great question, and we get that from many customers around the world. The first purpose is to control that asset in a reliable and trusted fashion. For that, SCADA protocols have been established. Ethos covers a wide range, whether that is the traditional 101, 104, DNP3, or the 61850 protocols. But that's only one aspect. As I mentioned just before, the other aspect is the integration of the transformer in your asset and condition-based maintenance processes. For that integration, we offer typical industrial IoT protocol, typically an MQTT. So it's important we have two sets of protocols, one for control and operation, linking to SCADA, and one set of protocols linking into your asset database.
Thank you very much, Bastian. I have another question. What exactly can I measure on non-MR Germany tab changers, such as the TTC UZE or the GE made type or the RMV types? So these bolt-on tab changers.
So that is, we know how to make tab changes. And of course, we know best how to make our own tab changes and what the fingerprints of those tab changes are. Now, for those non-MR tab changes, of course, we understand the principles and the way they operate. But if we look at how to retrofit and what to measure, my recommendation would be to install the vibroacoustic measurement with MSENSE VAM, which allows you the constant monitoring of the noise signals and acceleration signals, and the system is able to learn the normal operation, to compare that with that maximum permissible curve, and every time you have you are exceeding that curve, or the timing gets delayed or moved, then the system automatically gives you a warning or an indication to go into details. So MSENSE WAM is the sensor to monitor non-MR OLTCs.
I'd like to add something.
Please.
Well, I would say it with less words. I would say everything is possible from the packages instead of the torque monitoring, like you explained, because we need the fingerprint from the factory, and the contact wear calculation, because we don't know the material constants from the other manufacturers. And all the other packages are the same.
Yeah, exactly. MCI,
basic,
motor current index,
exactly,
is of course a complementary monitoring.
And counting the digital input from a dry contact, reading in that, it's the same for all. Yeah.
It's a great input, Christian. Thank you, and Bastian. The next question, is it possible to upgrade a power transformer to become intelligent?
So yes, it brings me back to my first aspect when you asked about intelligence. How can we upgrade a traditional transformer to become intelligent? So the first step is to install an edge computer, which we call ETOS, the Embedded Transformer Operating System. That system collects all data, establishes a history, performs the comparison, and provides the automation to translate or to transform that transformer from a big piece of iron into an active asset, which is highly automated, which even can go beyond its traditional design envelope, because it allows you to pre-cool, to predict the loading and the temperature patterns. So yes, I think the answer is having a powerful edge device such as ETOS, which is much more than an SPS or an PLC. I hope I could bring that and convey that idea, which is much more than a PLC. Christian?
Yes, and from the practical side, I would say if you like to update or retrofit an ETOS system at the existing transformer, first of all, of course, we need an investigation. Let's check what are your requirements regarding the monitoring for this specific transformer. It doesn't make sense to take the complete oversized monitoring package for a small field transformer, I would say, depending on the importance of the transformer. And of course, the form factor is something very important. So if we are speaking about to add the complete package, for example, with the cooling control, we have to check if there is a space outside. If you maybe don't need a new cabinet, maybe you only want to have the raw, let's say that the naked edge computer, what we are able to install in the existing cabinet. Yeah. So we are very flexible in the needs of the customer.
Thank you very much. The next question, what kind of sensors and actors could I connect to an open system like ETOS?
I mean, from the sensors, we mentioned already a couple. There are a couple of sensors which we have not yet touched. For example, bushing monitoring to supervise the bushings, connecting partial discharge monitoring, ensuring that we keep track of all the partial discharge activities within the transformer, and also there look at the acceptable range of partial discharge activity. We have the more advanced DGA-9, which tracks all ranges of fault gases, of error gases. Can you think of additional sensors?
Well, I would make two clusters. Let's say the common sensors we all know maybe, or all customers know around the transformer, like you mentioned, all of them. Therefore, for example, you are able to connect them in two ways. Let's say your Ethos is equipped with MR sensor bus, what is nothing else like a Modbus RTU connection, what is supported by the most common sensors. It's very easy and flexible to connect them or to expand the complete system. We have like a fixed library in the Ethos system. So let's say in similar a few minutes, if the physical connection is done, you only go there in the settings, go to the special settings, and you look for your sensor. There are also sensors from other third-party manufacturers. It doesn't need to be a sensor from us. Also,
Sure.
That's very important for retrofitting. And if you have not the chance or the sensor is not equipped with Modbus RTU, it's still possible to connect them via the analog module to transfer like gas ratings. And beside all of that, if it's not a common sensor from the energy world, let's say, but you also like to add something for the weather, we have the common standard units, SE units, over 80 SE units prepared in the software. So you only choose what is the incoming signal, let's say 4 to 20 milliampere or 0 to 10 volts. And then you choose the common SE units like pressure, what else, what do you imagine, Kelvin, and so on.
No.
Yes.
So basically we have an open system.
Yes.
We can connect our own sensors. We can connect third-party sensors. We are open for the future because we are simply able to use all the ISO standard measurement units. And as progress in the field of sensing,
Yes.
a customer can integrate today's sensors and future sensors.
Yes, and if all this is not enough, write an email and we make it possible.
Ah.
Great, thank you. I have another question from a customer again. I wonder how beneficial the concept of the intelligent digitalization would be for dry type transformers.
Yeah, dry type are a special type of transformers. Certainly, the design has an influence. Other than that, the criticality of the transformer is relevant. Certainly, there is a couple of ideas which comes immediately in my mind, which makes no sense. I mean, there's no DGA in a dry type transformer. Therefore, there are certain sensors which make no sense. Pressure relief, oil flow, oil level, and all of that does make sense. But we also have the main components in OLTC. We have a winding, we have bushings, and those needs to get monitored, supervised in order to avoid any deterioration or excess loading. Do you have any practical examples, experiences?
Honestly, I'm not familiar with the dry type ones, but just to think logically, I would say temperature management is as well the same or similar to the oil-filled ones. So, therefore, if there is temperature is a need to monitor, it's, let's say, the same, basically. Let's discuss. I'm not sure if maybe also FO probes can be added. So let's say the MSENSE FO system maybe also can be added for the temperature management. If maybe, I guess they also have to be cooled.
Yes.
I'm not sure.
Sure.
But if so, we also have the possibility to add the cooling control.
Yes.
Also frequency control maybe. What else? Yes, protection devices also. Maybe not the ones who normally react over the oil, but I'm not sure what's there. We have to investigate it, and after investigation, I'm sure it's similar the same.
I think, you know, the concept of the intelligent digital transformer is the same. Now, for a dry type transformer, you have a different set of applications, different set of sensors, but all the aspects, what makes a transformer intelligent, the benefits you get from a digitalization and integration in your asset management and maintenance processes is identical. And yeah, I agree with you. There's not so much difference from an intelligence and maintenance perspective compared to oil type transformers.
Just imagine the maintenance planning also can be performed equal. So the benefits are the same, and you have the continuously online data.
Exactly.
24 hours, 7 days.
You build the history, you track the correct pattern, and recognize any deviation.
Yes.
So, Peter, what's next in your?
The next question I received: what are the factors of influence for a power grid by using a connected transformer?
What are the factors on the power grid by using a connected transformer? I think the connected transformer has two main abilities in the network. First, it increases resiliency because you're always aware about the condition, health situation of the transformer, and you can avoid and plan for, you can avoid unplanned outages. And if there is a maintenance needed, if there is an intervention needed, you can plan for the outage. So the digital transformer will give you advantages here. The second aspect is that the transformer will increase your ability to take on renewable and highly volatile energy, because with the mentioned intelligence, you can overload, and shortly, for a short time, you can overload the transformer, manage the peak of incoming renewable energy, and by that, always taking an informed decision whether you take the renewable energy. You may be shortening the life, or you accept the redispatch penalties if you decide not to take that renewables. So gives you much more flexibility in maintenance, flexibility in operation.
Thank you very much. One last question for now. Is asset management part of an intelligent and connected transformer?
Yes, I would say yes. I think about, if you think about the maintenance philosophies, there you change, or you are able to change from time-based maintenance to a condition-based maintenance. So, yes, I would say.
And you can do that with using the MQTT protocols to really, I mean, there are two things I think you mentioned: the dynamic health index, which gives me an indication, about the asset, and then if you want to track the data, you can connect it with MQTT to your asset database.
Exactly, and there do more data science, let's say. Plot the whole data and correlate the data with maybe equal transformers.
Yes, so doing fleet analysis.
Exactly.
Oh, perfect. Thank you, Christian.
Great. Thank you very much, Bastian and Christian. So we're done with this FAQ round. Our chat is not yet done, so our experts are available for today, for tomorrow, and for Friday. So once again, thank you very much to the both of you.
Thank you, and
Thanks for listening.
have the final words to Peter. Thank you. Bye-bye.
Bye.
So it's time for Enders for today. So this first day, I want to bring a big thank you to all of our presenters who did a really awesome job here on the stage with their live presentations in front of the camera. Also, thank you very much for our team, all the techniques and all the support here in our studio in Regensburg. Awesome job, guys. And last but not least, but most important, thank you very much to you guys, our dear customers out there who gave us these good questions and always coming back to us, MR. So we will be back here tomorrow, starting at 9 o'clock with the next session. And once again, thank you very much for watching. We hope you enjoyed the show. Goodbye for today.